So earlier we saw quality of service is making router to differentiate traffic, which is not by default. Routers don't know to differentiate between management traffic and less important traffic and most important traffic. Routers can't differentiate. According to router, all traffics are traffics, whether it is voice or video or time sensitive traffic or less important. For routers, they are not in any way matters. They're all same traffic. So router will do normal QoS, which is called FIFO, first in, first out. So when router gets that knowledge how to differentiate these traffics, you can tell the router to provide some special services for those special traffics. This is not the only QoS. QoS is also telling router which traffic to sacrifice in order to save the most important traffic. See, when you don't have enough bandwidth, when the roads are narrow, you have to sacrifice some traffic so that at least a few other traffics can be served. If all tries to go through the narrow road, not possible. So what these people do, the people who maintain the traffic, they stop all these big vehicles, allow those two-wheelers to go. If you see in India, two-wheelers will be there in every small gap. They will go and fill all the gaps. So during the peak hours, they want to allow those two-wheelers first so that those gaps will be free and people in four-wheelers and six-wheelers can somehow manage to go without hitting anyone. So during that heavy traffic, in the cost of big vehicle, the small vehicles are prioritized, allowed in. Likewise, even in networking, when the congestion happens, the big traffic, the bandwidth killing traffic, the bandwidth hunger traffic, hunger, it's too hungry, wants to have more bandwidth. Such traffics are either delayed or dropped so that those tiny traffics, those time sensitive traffics won't get delayed. Those important traffics won't get delayed. They will easily get forwarded. If you don't do that, what happens is this bandwidth hunger traffic goes and blocks the entire bandwidth for a long time, and this tiny packets and time sensitive traffics, those important traffics, wait and get delayed and sometimes get dropped. And those traffics that get dropped, if it is recoverable, then it is okay. But problem is all those multicast traffics, those voice traffics, video traffics, they're all streaming using UDP and multicasting. They cannot be recovered. If it is TCP, yes, we can resend it, we can recover it. So QoS is telling the router that these traffics are irrecoverable, cannot be recovered. So if there is a congestion, you can drop those maybe FTP traffic, maybe those HTTP traffic, because they can be recovered. Why? How? Because they are TCP based. So we are telling those routers that if congestion happens, it's okay. You can stop those big jeep and car and bus. Allow those two-wheelers, let them go. After that, you can allow this four-wheelers and six-wheelers to go. That is QoS, which is not there by default in most of the routers. But on the high-end devices, on the high-end devices, there are some hardware level QoS available. For example, in the ISP track, we have iOS XR devices, ASR 9000 devices. Their line cards come with inbuilt QoS. There will be 3 or 4 tunnels even on the motherboard. On the motherboard. So when traffic comes, even before you enable some QoS, there will be already a QoS which can identify those management traffics and put it in one queue, and those time sensitive traffic and put it into some QoS which is already there on the high end devices. And if you want more than that, if you do not fee if you don't see that they are sufficient enough, then you can go and add additional QoS. So mostly you will be doing QoS on those small devices like Cisco iOS router. In iOS XR and XC, those service provider category devices has got already the QoS in place. Okay. So we are going to go in depth about learning QoS, the concepts of QoS, the classical Cisco iOS QoS, MQC, modular QoS over CLI, MQC. It is nothing but a 3-step approach in configuring QoS. Modular QoS over command line. We have 3 steps, like first we classify the traffic. Secondly, for those classified traffic, we set some priority, or we set some sort of policy in prioritization, and then at last we apply the QoS over the interface or to the CPU. You might have heard about the word control plane policing. Control plane policing is QoS over the control plane. QoS enabled globally, not on a specific interface, globally to the CPU, telling the CPU that if this is the traffic, then you first process this, stop the other process. Likewise, we can specify where to check for this QoS, where to apply this QoS, whether to be applied globally or over the interface. And then implementing, that's what actually I'm implementing QoS. And then types of applications and traffic patterns. Different application have got different traffic, different type of traffic. As I said sometime earlier, some traffics are time sensitive, some traffics are um, though it is not time sensitive, it's still important because it's the business traffic, not simple traffic like Facebook or LinkedIn. Fine. Next is QoS components. As I said earlier, we need to first classify. How do you classify? Classification can be done based on the access control list or based on the DSCP, differentiated service code point. This is a kind of marking. If packets are marked with DSCP value EF, they are called as high prioritized. So you can match some traffic using an access list. In the access list, you may say if the source IP address is this and if the destination IP address is this. That's one way of classifying. The other way of classifying is someone has already applied QoS on their router. Someone might have already applied QoS on the first router. With a QoS marking, the packet comes to the second router. So again, you no need to match with the access list. You can simply match with the marking which is already done in the previous router. So the marking, if it is layer 3, they will use DSCP or IP precedence. If it is layer 2, then the marking will be COS. Please try to understand. You have a router and some traffic is coming. This is the first router where you want to apply QoS. Then you may need to write an access list matching some traffics, and then you may mark it with some DSCP value. Now with the marking, when the traffic goes out, you set some priority. Not only that, the packet goes to second router with the marking. Marking is already done on router 1. Now on the second router, you no need to again write an access list matching some IP addresses. You need to simply match with the traffic that is having the DSCP value set. For example, if the packet is having DSCP AF31, what sort of bandwidth to AF31 is a kind of marking in DSCP. So if a packet is coming with this marking, you want to provide some special service. So you can even classify with this DSCP value or COS5. A packet is coming with marking because someone has marked the traffic with COS5 here on first router. So when it comes to the second router knows a packet with marking 5. When it receives the packet, these packets are marked with 5. So now you need to simply match with those marking and provide some service. I was telling you in the previous class, QoS need to be done on every single router. It's not end-to-end. End-to-end is called as integrated service, in-serve, which is not really recommended. Only protocol like MPLS, RSVP traffic engineering uses it, but again, it is not recommended. It's very costly. Because when you reserve the resource between end to end, others cannot use it until you finish using it. So, integrated service is not really recommended. Differentiated service is what seen most of the places. What is differentiated service? Providing QoS for the traffic on every single hop. It's not point to point every single hop. Okay, so now we got markings. You can match with that marking. That is also one way of classification. So next is marking and mutation. Marking is used on the traffic to convey specific information to the downstream device in the network. When I say COS 5 for some traffic, and when I say COS 2 for other traffic, what I am conveying is to the downstream, means for switch 2, for the router 2, what I'm saying is, hey, this is more important traffic than this. All those traffic coming with COS 5 is more important for me than COS 2. So if there is a need for you to drop some traffic, don't drop this one because this is high priority, means highly high preference traffic. That's why I've given COS 5. You may drop COS 1. Even after dropping COS 1, if there is still a problem in the bandwidth, if you don't have enough bandwidth to send traffic, then you may drop COS 2. Keep dropping COS 2 till the the traffic comes under the control. So even if there is too much congestion after dropping COS 1 and 2, then it won't drop COS 5 traffic, it will drop only COS 3 traffic, if any. So by marking, what I'm conveying is to the downstream, I'm conveying that the traffic with this is more important than this for me. Marking is used on the traffic to convey specific information to the downstream network devices or carry information from one interface in the device to another. When traffic is marked, QoS operations on that traffic can be applied. So marking is done by the classification so that you can take some action called a policy. QoS operation. QoS operation is what? The policy. Like shaping and policing, which is coming next. That is what QoS operation. This is one of the operation of QoS. So when traffic is marked, QoS operation on the traffic can be applied by using the command set. Yep. Now let's go to the shaping and policing. Shaping is like parenting. Parents are shapers. They shape the children. Policing is opposite. Policing is you have violated the rule. Either you pay the fine or go to jail. No parents will do that, right? But police will do it. Policing is harsh. Shaping is soft corner. So what is policing and shaping in networking? Policing is like, hey, this excess traffic need to be at once dropped because it is exceeding the rate limit. That is policing. Shaping is, okay, this customer is a sweet customer here, send me excess traffic. Instead of dropping the traffic, what we do is those excess traffic we slow down. We don't provide service immediately, but we will provide a bit late. Policing is like drop all those excess traffic, which is going to be a kind of denial of service for the customer. Few years back in India, I had a connection where you can use up to 200 GB of download per month. And if you go beyond the 200 GB, what will happen, The speed of the internet will go from 100 meg to 1 meg. 100 meg to 1 meg. So what is happening is it is slowing down my traffic. Earlier it was 100 meg when it was within the 200 GB tariff. When I consume more than 200 within a month, from that minute, from that second, as soon as I reach 200, the speed of the internet will go down to 1 GB. I'm not denied service, but I am not able to download anymore like before. If it takes 2 minutes to download, now it will take 20 hours to download. Even after that, it's not possible sometimes because the speed has been reduced to 100 times. But service is there. Still, you can check the mail with that 1 GB speed. That is what called as shaping. Policing is completely deleting those excess traffics. Shaping is take those excess traffic and put it in a different queue which is slow. Yeah. Okay, let's read here. Shaping is a process of imposing a maximum rate of traffic while regulating the traffic rate in such a way that the downstream devices are not subject to congestion. Okay, I agree. You see, shaping customer will do. Policing service provider will do. That's what I understand from this first two line. You may not understand that, but that is what they actually mean. Let me tell you what it is. See, you are using internet, but who is providing internet? The service provider. Definitely service provider will do policing, but you will not do policing to your own traffic. Will you delete your own traffic because it is going more? No. Instead of you sending more traffic and getting dropped on the provider side, what you will be doing is you will be doing shaping. What is that? Before sending the traffic out, you will send it in a controlled manner. You will send it within a limit that is acceptable by the provider so that your traffic won't go to the provider and get dropped. So what you are doing is you are slowing down your traffic to match with the agreement that you have made with the provider so that the provider won't delete, drop your packet. In case if you send more without shaping, the provider is going to drop your packet. Whatever is within the limit, provider won't drop. But when it goes beyond the limit, if it exceeds, then the action taken will be drop. That's policing. Now let's read. Shaping is the process of imposing a maximum rate of traffic while regulating the traffic rate in such a way that downstream devices are not subjected to congestion. So downstream devices won't face congestion because you are sending with a limit. Shaping in most common form is used to limit the traffic sent from a physical or a logical interface. Policing is used to impose a maximum rate of the traffic class. If the rate is exceeded, then the specific action is taken. What is the specific action in policing? Drop. Policing is when it goes beyond the limit, it takes the action like drop or reset the connection, something like that. Shaping is when the traffic tries to go beyond the committed rate, when it tries to exceed beyond the rate, it's going to slow down. so that it will be within the rate limit. Before sending, every customer should do this, so that unnecessarily the packet will not go get dropped and resent again, get dropped and resent. Queuing. What is queuing? Queuing is placing the classified traffic in different channels with different bandwidth. Virtual queue, I can say. It's not a physical queue, so that the traffics can wait for a while in that queue, in a buffer. So queuing is like a buffer. You create some buffers and put them into the buffer. Sorry, you create some buffer and put the traffic into the buffer, so that they will halt for some time before, till every important service gets served. The less important traffic can wait for some time instead of getting dropped. So what is queuing? Queuing is used to prevent traffic congestion. Okay, good idea. Instead of having every traffic in one common hardware queue, we create multiple queues so that different traffic goes into different queues. As a result, there is congestion avoided. Traffic is sent to specific queues for servicing and scheduling based on their bandwidth allocation. Traffic is then scheduled and sent out through the port. When I say through the port, what does it mean? The physical port. The physical port has got what? Hardware queue. Every physical port has got a hardware queue. So before scheduling the traffic into the hardware queue, we place the traffic in a buffer with some bandwidth, so that they can halt and get served. Instead of getting dropped, they can halt for some time. When the hardware queue is full, the software queues will be holding the data. Otherwise, the data will get lost, dropped, tail dropped. What is bandwidth? Bandwidth allocation determines the available capacity of traffic that is subjected to QoS policy. So how much you allow the traffic to consume? What is the limit that you want to set? Within what capacity, if traffic comes, the router will be happy? That is what bandwidth is. Bandwidth allocation determines the available capacity for the traffic that is subjected to QoS policy. Next, trust. Trust enables traffic to pass through the device. See, there is a concept called DSCP trust, COS trust. What does that mean? If already packet is marked, you see the packets are marked as COS and DSCP, and it is coming to R2. On this port, if you say COS trust or DSCP trust, R2 will simply copy whatever is coming in without doing any changes. See here, cos 5, you might have given for voice over IP traffic. When it comes to R2, if you wish to give the same treatment, then you need to simply trust. You no need to do anything. Trust meaning, if it is given high priority here also high priority. If you don't say trust, then you need to specify how you want to treat voice over IP here. If you don't trust, what does it mean? You would like to give different treatment. Maybe you may be downgrading from COS 5 to COS 3 here. You may be mapping all the COS 5 packets to COS 3 so that in R2, less respect for voice over IP. So trust, if you say, then you are not going to do remarking. You want to maintain the mark, the value that is coming in. See? Trust enable traffic to pass through the device, and the DSCP precedence COS value coming in from the endpoint or retained. It is not changed, it is maintained or retained. It is going to continue even in this device which is receiving the packet, retained in the absence of any explicit policy configuration. So if you don't do any explicit policy configuration on R2, if I don't configure, like if I did not configure COS3, I simply said trust COS, which means if any traffic coming as COS5 will be given the same COS5. When it goes out of R2, it will go out as COS5. When a traffic comes with COS3, it will go out as COS3. No remarking. It is retained. Nice document. I did not expect this nice document. Good. So information about QoS. Low latency, bandwidth guaranteed, buffer capability and dropping disciplines, traffic policing, enabling the changing of attributes in the frame. This is too much. Right. What is this MQC? MQC is the way through which we apply QoS, configure QoS. So MQC is classifying the traffic, applying a policy, see, classify the traffic and use the classified traffic and apply the policy for the traffic, and then take that policy, assign it to the interface. Or you can also assign it to the CPU. So these are all few ways through which you can classify. DSCP, IP precedent, COS, QoS group, ACL, MAC ACL, IPv6 ACL, VLAN ACL. This HQoS is not available in all devices, it's only available in high-end device. Hierarchical classification. So in layer 3 header, you got this tag field. In IEEE 802.1p, the trunk .1q and .1p frames, this tag field is used for the COS. In layer 3 header, there is TOS, 1 byte, totally 8 bits are there, in which IP precedence will use 3 bit, DSCP will use 6 bits. Even in IPv6, you got 1 byte, but the name is traffic class. In IPv4, it is TOS. So if you take COS, it is only 3 bit. You will get 7 different priority. 0 is low priority, 7 is the high priority, in which 6 and 7 are reserved for management. In DSCP, I was telling you yesterday, there are 6 bits, so 2 to the power of 6 is 64 different QoS. In COS, in COS and IP precedence, there is only 3 bits, so you will have 00, 001, 010, 011, 100. Likewise, up to 111, totally 7. If you have 3 bits, it is only 7 different prioritization level you can apply. But if you are using DSCP, differentiated service code point, this uses 6 bit. As a result, you will have 2 to the power of 6, 02s, 63 different QoS markings. So end-to-end QoS is good, but you cannot use inserv. Instead, you should use what? Diffserv. Diffserv is what highly recommended. All right. See, what is MQC? MQC is first classify using class map. In the class map, you may be matching with the access list or any IP precedence or COS values. And then in the policy map, you provide the action. You provide the prioritization, the policies. So I would like to show you an example. Okay, this is talking about the COS and the IP precedence. Both COS and IP precedence uses only 3 bit. If you have no QoS, then it is 000, which is normal, routine. If you have 1111, it's highly prioritized. Again, I tell you these two are reserved. You see, for the inter-network control and then the network control, meaning it is meant only for OSPF, BGP, CDP, SNMP, all those management traffics. So from 5 onwards, from 5 to down to 00 is what we can use. So all those critical traffics you will assign 5. So when you say 010 or when you say COS 5 or IP precedence 5, you are conveying a message to the downstream device that I want to give more priority to this packet. Again, if the downstream is ready to trust, then downstream also will give high priority. If not, there may be a remarking. So classification can be using MAC ACL or class of service or VLAN IDs. I'm actually, okay, let's read this. Trafficless classification. Distinguishing the packets or the flow from one another. I told you there are different type of traffics. EIGRP is one type of traffic. Your voice is another type of traffic. Your ICMP is so there are different type of traffic. We need to classify them by writing an access list or matching with DSCP or COS values. Secondly, traffic marking and policing is assigning a label to indicate the given quality of service as the packet moves through a device and then makes the packet comply with configured resource usable, meaning if the limit is reached, what to do with the packet. Should I police or should I mark it and shape it? See, understand. If you are doing policing, what does it mean? You are going to drop the traffic, or you can also mark it with some other QoS value so that the traffic will go in another slow queue instead of getting marked. Instead of getting dropped. So you can remark so that it won't get dropped, which is called shaping. Shaping is ensuring the traffic sent from the device meets the specific traffic profile. So make sure the traffic don't get lost. For that, whatever the necessary queuing need to be assigned. Assigning it is what called shaping. Okay, queuing and scheduling provides different treatment to all the situations where the resource contention exists. So whenever there is a congestion, whenever there is a resource contention, but that's what congestion is. When the resource is not enough, the traffics are treated in such a way that important traffics never get dropped or slowed down. So you can apply these QoS both in ingress and egress. In ingress, you can have classification, policing, and marking. On the egress, you can also have shaping. That is what queuing, putting them in different queues. All right. So there won't be a tail drop. You just put it in wait so that there will be a weighted tail drop. If you don't have QoS, what will happen? When the buffer is full, the packet will get dropped. Instead, you put them in a different software queue so that they will wait there. And then, based on the weightage, the drop will happen. The packet with the high weightage won't get dropped when there is a congestion. The low weightage traffic, the low marked traffic will get dropped. So, one thing you need to be very clear that QoS is not doing any magic here. QoS is like comparing the traffics and dropping those less important traffic to save the highly important traffic during the congestion time. So, as we already saw, classification can be done through ACL. You call under the class map, and then action need to be taken in the policy map. All right, so let's quickly see an example. Look at this fine example. Fine example. But the problem is this is empty. I don't know why they do empty. Class map, they give a name C map, but they did not match anything here. Nothing is matched. And then a policy map, they're calling this class map. And okay, this is simply syntax they're explaining. Okay, there is no example here. They're calling the class map and setting some priority, not mentioned. And then inside the same policy map, you also call another class map. What do they teach here? You may create multiple class maps, but you don't need multiple policy map because under the interface you can have only one policy map. You cannot have more than one. So put all those class maps and set the necessary priorities and call the policy map under the interface like this. It can be output or input. Here they show you egress QoS egress. Actually speaking, there is only one thing that I want to teach, which is DSCP value, how to read them. All other things are already covered. The other things that you see here are not really that important. And then different type of queuing methods. Our queuing method like LLQ and class-based weighted fact queue is what I want to cover. I already covered in the previous class. See, COS 6 has got more bandwidth prior to COS. You only said this percentage actually. So DSCP is up to 64. Here they are showing how COS and DSCP is mapped. By default, any packet with COS 6 is considered as DSCP 48. 3 is considered as 24. DSCP you will have up to 0 to 64, no? In that, how the COS can be mapped. See, if a traffic is coming from a layer 2 switch, layer 2 will only have COS. But you are receiving that layer 2 traffic into a layer 3 device. Now, what sort of QoS that you will give for those traffic that is coming with 6? You will give DSCP of 48. This is default. So if it is COS 5, you give DSCP of 56. 56 DSCP is also called as expedite forwarding, EF. So DSCP to COS marking, DSCP 0 to 7 means COS 0. So if a traffic is going from a router to a switch, router may send with the DSCP of 39. How it is treated in switch? COS 4. This is default. You can also change those weights. Okay, here comes an example. I don't want this type of example. I want everything in one page. You see, we have an access list matching traffic coming from 10.4 going to this one. I don't know why it is getting selected like this. Okay. Oh, no, I don't know. Anyway, this is the access list, and you go under the class map, and you're calling that access list inside the class map. Afterwards, you will call that class map to a policy map. Yep. So that is one way of classification. There is another way. There are a lot of mapped traffic coming from the upstream. You are now matching those marked traffic. Maybe layer 2 switch is sending traffic with COS 3, 4, 5. Now on this device, it may be a switch or a router, I don't know. They are just matching all the traffic which is already marked with 3, 4, and 5. So class map can match with an access list or can match with the traffic which is already marked. It can also match with the packet which is already marked with a DSCP value, afforded forwarding 21, 22, 23, I say up to 64 you can have. Alright, it can also match with VLAN numbers. So only those traffic coming in that VLAN. It can also match with IP precedence or DSCP EF. EF is expedite forwarding, means highly prioritized. And then, come on, they call those class map, you see C1, which is matching with the DSCP 30, is set with priority level of 1. And then there is a police 20% of bandwidth if it consumes. Then transmit is the action, means it is allowed to transmit. If it exceeds, the police will drop the traffic of those traffic coming with the DSCP value 30. And then you need to apply this on the interface at last. This policy map need to be applied on some interface. You can also call the class map under a policy map and set some bandwidth so that there will be a queue created with this bandwidth, and whatever is C2 matching, what does that C2 matches? All the packet with IP precedence 4 is given a queue with a bandwidth of 2 meg, 2 meg or 20 meg. All right. So here, what you see here is there's nothing called table map in a normal router. I just want to show you where it is applied. They will apply it to the interface. A lot of examples they show. You can go through these things. Okay. You call the policy map, which has got the class and then the rate limit, whatever, under the interface, and say when the traffic goes out, do this action. That's all the QoS. All that I need to do is I need to show you a demo QoS, and also I want to teach you one very important thing which is not in this presentation, the DSCP values, how to read them, the meaning of it. So these are the two things that I will show you tomorrow. The DSCP values, how to read them, what do they mean when you say AF31 or AF42, and then I'll do one demo on QoS. Maybe for ICMP traffic or telnet traffic, I'll set some limit and I'll show you. Right. So one more day of